So for physics problem examples explanation, I chose your test review, like if we're in a classroom and we're preparing for the test. These are the questions that you would want to review before the test, or if you are in a classroom preparing for the test, these are the questions you want to review. So here's number one, the speed of a transverse wave. And if you remember, the transverse wave is like transverse. The motion of the transverse. The motion of the molecules inside of the wave are perpendicular to the motion of the wave. So the motion of the wave moves forward, the particles of the wave and the transverse wave move perpendicular. That means up and down. So the speed of a transverse wave in a string is, so the speed is given 12 meters per second. And the frequency of the source producing this wave, so the frequency of the source producing this wave is 3 hertz. What is the wavelength? And the formula that you learned in this section, the velocity of the wave is equal to the wavelength over the period. And the wavelength, so if this is the wavelength is the distance between the crest and the crest, so how long this is, or the trough and the trough, or any points at the same position of the wave. So that would be this part. So if I plug into my equation, so it's the wavelength over the period, and one over the period is frequency. So sometimes you can see the formula written this way. So now I'm going to plug it into my formula. So the wavelength is equal to the velocity over the frequency. The velocity is 12, the frequency is 3, so that is 4 meters. The next question says, which best represents the periodic wave traveling through a uniform medium? So in the uniform medium, the wave, I wanted to tell you something here as well that I did not mention in the lesson. The wave is produced by the mechanical vibration. Mechanical vibration is, so if somebody has a rope and shakes 10 times within 1 second, the frequency is 10 hertz. So depending on how many vibrations happens in 1 second, that's the frequency. The frequency depends on the source. It cannot be changed. The source just produces a certain frequency and that's it. But when the medium is traveling, like remember we were talking in the lesson, if the medium travels different matter, like solids, liquids, and gas, its speed is changing. So if you have the formula, V is equal to the wavelength and the frequency. If frequency does not change because it just attached to the source, so wherever the source is producing, no matter what happens to the medium, the frequency does not change. But the velocity changes. So the velocity went down, then the wavelength needs to go down in order for the frequency not to change. So if the frequency doesn't change, you have this formula. So if the velocity went down, then the lambda needs to go down. If the velocity went up, then the wavelength needs to go up in order for the frequency not to change. And the velocity will depend on what medium the substance is. So in this case, the wave is. In this case, which diagram best represents periodic, that repeating over and over, transferring through the uniform medium? So because uniform medium, that means the medium is not thicker or thinner, velocity is not going to change. So the frequency and the wavelength should not change. This one has change in wavelengths and the amplitude. This one has change in things. This one is just one wave. So it looks like B. So for number 3, the number of waves passing a point in the unit of time is called frequency. So how many waves pass a point in a second is frequency. The next question is the wavelength, just to go over it. The wavelength is the distance between 2 points of the wave on the same position, amplitude, how far it's displaced, and period, how long it takes to make one full wavelength. In 4, as shown in the diagram, a transverse wave is moving along a rope. And in which direction will the x move as the wave passes through it? So as the wave will get closer to it, so the wave is going to go next this way, right? So x will have to move up. And so if the wave approaches x, the first motion is going to be up and then down and then this way. So the answer for this one is up and then down. In number 5, the diagram shows two waves traveling in the same medium for the same length of time. The two waves differ in what? So I see this one has this much amplitude, this one has this much amplitude, but they have the same crest and the same time, same trough the same time. So it looks like they have the same period. It looks like they have the same wavelength, but they have different amplitudes. So here is where the answer comes from, amplitude. So if they have the same period, they have the same frequency, if they have the same wavelength, so the length from here to here is the same for both waves. And if they have the same frequency, so same time means same frequency, they will have the same speed, but the amplitudes are different. Next question says, which graph best represents the relationship between the frequency and the period of the wave? So your frequency is y is equal to mx, right? Y is equal to, in our case, we have 1 over t. So your t can never be equal to 0. So in this case, t is equal to 0. In this case, t is equal to 0, period, right? And in this case, t is equal to 0. In this case, t is never equal to 0 because this is the hyperbolic relationship when neither one of them approach 0. They get closer and closer, but never approach 0. So the answer would be D. For number 7, a hiker shouts toward a vertical cliff. The echo is heard 5 seconds later. How far is the hiker from the cliff? They didn't tell you the velocity in number 7. So in number 7, they didn't tell you the velocity. So I assume the velocity of the sound is 340 meters per second. Every time they don't tell you the velocity of the sound, that is 340 meters per second. And echo heard 5 seconds later. So if here's the hiker, and he shouts the wave, sound wave, toward the cliff, it returns, so it takes there and back. This takes 5 seconds, but it takes 2.5 seconds to get one way, 2.5 seconds to get one way. So if I want to find how far is the hiker from the cliff, the distance, I need average velocity, and the velocity of the sound does not change unless the medium changes, so that's 340, and times the time. So I have 340 times 2.5, and looks like that's going to give me 850. For number 8, what is the speed of periodic wave disturbance that has a frequency? So they give you the frequency. Frequency is 4 hertz. So for number 8, 4 hertz. And the wavelength is 0.6 meters. And they ask you to find the speed. So the velocity of the wave is equal to lambda times the frequency. So that gives me 2.4 meters per second. For number 9, a low frequency radio wave, electromagnetic wave, speed is 310 to the 8 meters per second. So the speed of light, or all electromagnetic waves, is 310 to the 8 meters per second. So it's good to remember that the speed of light, and sometimes they use the letter c, is equal to 310 to the 8 meters per second. So this is a good number to remember. And you have seen this in E equals to mc squared. This c is speed of light in this case. I will mention this in our light videos. I only did sound videos for you, or mechanical videos for you because it was getting too long, 30 minutes. So I'm gonna do a different one, maybe shorter, like 10 minutes for the light. And I'm just gonna bring it up over here as well. So all electromagnetic waves produced by like the sun produces all the electromagnetic waves, and they go from radio, the longest wavelength. So you see the wavelength is the longest. So if I measure between crest and crest, it's going to be the longest wavelength, to gamma rays, which one is the shortest wavelength. So the wavelength is very short right there. And in between, somewhere in between, you're going to have a visible light. So it goes between the red and purple, and then goes ultraviolet. So you have radio waves, microwaves, a little bit shorter wavelength, and then infrared, and then visible light, and then ultraviolet, and then X-ray, and the gamma rays. And one of my former students taught me, I guess they teach students in middle school this way. So Red Monkeys invented very useful Xbox games. So you can remember it goes from the longest wavelengths, radio, to the shortest wavelength, gamma. And also it goes from the lower frequency. So longer wavelength has lower frequency, and shorter wavelength will have higher frequency. So right here at the end, you have higher frequency. I just wanted for you to see that. Oh, the also interesting fact, if you take electromagnetic wave and look at it, we only can see, our eye can only see these frequencies. So it's between 10 to the negative 5 to 10 to the negative 8. So any number between here, that would be what our eye can detect. And the wavelength of this frequency is the frequency is 10 to the 15th, and the wavelength is between 10 to negative 5, 10 to negative 6. So pretty tiny wavelength in frequency is pretty high that our eye can detect. But all of these electromagnetic waves, radio, micro, infrared, visible, ultraviolet, gamma ray, X-ray, all of them move at the speed of light. So they will all have the speed of light. So the velocity is given and has a frequency of 300 kilohertz. What is the wavelength? So velocity is equal to lambda over period, or lambda times the frequency. So I'm looking for the wavelength. The wavelength is the velocity over the frequency. So it looks like I have 310 to the 8 divided by 310 to the 5th, 10 to the 5th. So the wavelength is equal to, is that to the 5th, 10 to the 3rd meters, or 1 kilometer. For number 10, two sound waves are traveling through a container of unknown gas, so they have the same medium. If they have the same medium, then this wave is going to travel through that medium, sound wave, at certain speed. Have a wavelength, and they give you one wavelength, and they give you another wavelength. The velocity of wave B must be, and there is probably the number, the velocity of wave A. And because it is the same medium for both waves, it must be the same velocity for both of them. They will have different, the frequency will depend on their sources. They may have different frequencies. Their wavelength will depend on the frequency and the velocity, but the velocity is the same for them. But their velocity is the same because sound wave would travel at certain speed in certain mediums, and this is the same gas for both waves. For this question, 2 sound waves are traveling through a container of a known gas. Again, 2 sound waves in the container of a known gas. So again, they say have the same medium. The speed is the same for both of them. Wave A has a wavelength, and wave B has a wavelength. So they talk about the frequency. The frequency is equal to, I'm going to say the frequency of A is equal to the velocity of A, and they have the same velocity, over the wavelength, which is 1.2. And the frequency of B is equal to the same velocity for both, over 3.6. That is the same as V over 1.2 times 3 at the bottom. So that is the same as 1 over 3 times V over 1.2. And this is the frequency of A. So the frequency of B is 1/3 of the frequency of A. Number 12, you hear the sound of the firing of a distant cannon 5 seconds after seeing the flash. So at first you see it, and then 5 seconds later you hear, after 5 seconds after the flash, you hear the sound. They don't give you the velocity of the sound in this case. And because they don't give you velocity, you have to assume that the velocity of the sound is 340 meters per second. And they tell you the time it traveled is 5 seconds. So, and you calculate how far. How far means the distance. So the distance is average velocity times the time. And the velocity of the sound doesn't change in this medium. In one medium stays the same, so that's 340 times 5, and that gives you 1,700 meters. For the next question, for number 13, if you shout across the canyon and hear an echo 6 seconds later, how wide is the canyon? So if you're on one side of the canyon and you shout, the sound travels and comes back, and that whole process takes 6 seconds. That means one way it took 3 seconds. And the velocity of the sound they don't tell you, so again I'm gonna assume it's 340 meters per second. So the distance is average velocity times the time. So that's 10-20 meters. For the next question, number 14, a sound wave has a frequency of, so they give you the frequency. So for number 14, they give you the frequency of 9,800 hertz. If the distance between the compressions of a region of high pressure is 1 meter, so you have higher compression, rarefaction, higher compression, rarefaction, and again higher compression, rarefaction. So the distance between this and this, so that's the same as having the wave like this. When you have denser, that's a high peak. So this would be the crest and the crest. This is your crest, this is your crest. So the distance between them is 1 meter. So lambda is 1 meter. And the frequency is given. What is the speed of the wave? So the speed is equal to the lambda times the frequency. So that's 1 times 9,800. Gives you 9,800 meters per second. Number 15. A rifle is fired in a valley with parallel vertical walls. So you have a wall here and a wall there. The echo from one wall, so the echo from one wall is heard 2 seconds after the rifle was fired. So it takes 2 seconds there and back. So 1 second there and 1 second back. And the echo from the other wall, so it went to the other wall and then comes back, is heard 2 seconds after the first echo. So if it took 2 seconds for the first echo, there and back, then that means this one took 4 seconds there and back, which is 2 seconds there and 2 seconds back. So if the sound was traveling from one side to another, it would take 3 seconds. They don't tell you the velocity. That means the velocity is 340 meters per second. So the distance between, how wide is the valley? So the distance between two sides of the vertical walls is the average velocity times the time it's going to take to travel from one side to the other, which gives you 10-20 meters. Same type of question, number 16. Rifle fired in the valley with 2 vertical walls. The echo from one is heard 2 seconds after. So here is the rifle. The echo from one is heard 2 seconds later. So that takes 1 second one way. And the echo from the other wall is heard 4 seconds after the first echo. So that is 6 seconds together there and back. So that's 3 seconds. So the distance between here, one side, to the other side is equal to average velocity. They don't give you velocity, so that's again 340 times the time, which is 4 seconds. That gives you 1360 meters. A camera determines the distance to the subject by sending out sound waves, and they give you velocity in this case. So in this case, the velocity is given. And measuring the time needed for the echo to return to the camera. How long would it take the sound wave to return to the camera if the object is only 7 meters away? So they give you the distance, 7 meters, and they give you the velocity at which sound wave travels, 350 meters per second. And they ask you how long it will take, so that's the time. And again, velocity is equal to the distance over time, and this is just the same as if the car was moving, distance, time, velocity problem. So the time is equal to the distance over the velocity. So the time is equal to 7 over 350. That's the same as 1 over 50. So the time would be 0.02 seconds. So for the next question, number 18, 10 pulses generated every 0.5 seconds. So I'm going to say 10 in 0.5 seconds. Frequency gives me how many per second. So if I times both sides by 10, I get 100 in 5 seconds. And if I divide both sides by 5, I get 20 in 1 second. So from here, I know that the information that is given, that the frequency is 20 hertz. Then if the wavelength of these surface waves are 4 centimeters, so the wavelength is 4 centimeters, that's 0.04 meters. Find the frequency, period, and speed. So the speed is the wavelength times the frequency, so that gives me 0.8 meters per second. The period is 1 over the frequency, so that's 1 over 20, so that is 0.05 seconds. And the frequency, I just found the frequency is 20 hertz. And here's the last question for this video, so number 19. The time it takes for the wave to travel from its equilibrium to the crest is 0.2 seconds. So I'm going to make a wave right here. So here is the wave. So the time it takes to travel from equilibrium to its crest, 0.2 seconds. So if somebody measured this time, that would be 0.2 seconds. But full wavelength, so the wavelength would be from here, this part, back to the same position, right? So this is one wave, one full wave. So in the wave we have one of these parts, two of these parts, three of these parts, four of these parts. So the time would take from here to make one full wavelength would be 0.8 seconds, because there's 4 parts of 0.2. So here is my period. So they ask you to find the period in this question. And then to find the frequency, that's 1 over the period. So the frequency is 1 over 0.8. The frequency is equal to 1.25